All right, so our aim for today is how do we simplify trigonometric expressions. And the do now is to simplify the expression cosine t plus tan t sine t. Okay, so essentially all you want to do is, substitute one of the expressions. I'll give you a hint, it's tangent t. So tangent can be written as sine over cosine, and then from there, see what you can do with that. All right, would anyone like to offer up an answer? Like, what do they get for the final expression? Oh, yeah, Huyan. Huyan, did you raise your hand? Okay, you got a secant t. Okay, anyone else get something else besides secant t? Or let me ask, did anyone get secant t? Okay, we got 1 over cosine. Okay, yeah. So 1 over cosine, that could be further simplified to secant, right? Okay, so I guess you got the same thing then. Okay. All right. So good. That is the answer. So let me just scroll up to the solution for that. All right. So how this is going to work is we have tangent is sine over cosine, and Fuyan, do you have a mic? If you want to explain it, could you do so here? Or do you not have a mic? Okay. Yeah, I don't think it's working. Mira, what about you? Is your mic working?
Yeah, sure, I can explain it. So basically I rewrote the expression. I rewrote tangent t as sine t over cosine t. So you have cosine t plus sine t over cosine t times sine t. And if you multiply sine t by sine t over cosine t, you get sine squared t over cosine t plus cosine t. And then you can rewrite cosine t as cosine you can rewrite cosine t as cosine squared t over cosine t, add that to sine t squared over cosine t, and you would get 1 because of the Pythagorean identities, I think that's what they're called, and you would get 1 over cosine t, which could be simplified to secant t.
All right, very nice, very nice. So yeah, so in these questions, it's kind of like a puzzle, right? So you get like various identities that you can sub in for. So like tangent is sine over cosine, which is one of the reciprocal identities, right? Or I shouldn't say reciprocal. I should say a quotient identity. We didn't identify it in class as a quotient identity, but I believe in the textbook that's what they consider it as. But either way, tangent can be seen as sine over cosine. And then from there, we use the Pythagorean identity, sine squared t plus cosine squared t is 1. And then from there, we use the reciprocal identity, right? 1 over cosine is secant, right? So just pull in multiple different pieces to solve this expression. Okay. So the rest of class is just, the only notes for today is just a review actually of the identities that we've seen so far. So let me get to the slide. And then after that, it's just the classwork. Okay. So Nothing really new today per se. Just a matter of applying what we know. Okay, so let me zoom out for this. All right. Can someone read the first section? So the reciprocal identities. And yeah, Terry.
Yeah. Okay. So A is reciprocals, like that's the first section. Cosecant of x equals 1 over sine x. Secant of x equals 1 over cos x. And then cotangent x equals 1 over tan x. And tan x equals sine over cos. Cotangent equals cos over sine.
All right, thank you for that. So yeah, they do now. We saw these two, right? Secant is 1 over cosine, and tangent is sine over cosine. Okay, and then can someone read the Pythagorean identities?
Sine square x plus cosine square x equals 1. 1 plus tangent square x equals secant square x. And 1 plus cotangent square x equals cosecant square x.
All right, thank you for that. So yeah, for these, we also had, mnemonics, right? So if you remember, well, does anyone remember the one for 1 plus tan squared x?
I tan by the C. I remember that.
All right,
That's
very
the
nice.
only one I remember, by the way. I don't know.
Okay. All right, I tan by the C. Yes, very nice, very nice. So that's the one for 1 plus tan squared x equals secant squared x, and that's just like one. I represents 1, and then tangent, right? And then C is secant. Okay, but you just have to remember that tan and secant are squared. Okay. All right. Anyone remember the one for this one? Yeah, Dorothea.
I think it was like I buy coats at like Costco or something.
Yeah, very nice, very nice. Okay, yeah. I buy coats at Costco. So I again represents 1, coats is cotangent, and then Costco is cosecant. Okay. All right. And then last but not least, we have the even and odd properties. Any volunteers to read that one?
I hear sine of negative x equals negative sine x. Cosine of negative x equals cosine x. Tangent of negative x equals negative tangent x. Cosecant of negative x equals negative cosecant x. Secant of negative x equals positive secant x. Cotangent of negative x equals negative cotangent of x.
All right, very nice, very nice. Okay. There was like one mnemonic we talked about. Well, I think I said it in a video. Did anyone happen to remember it? It's with regards to like cosine and secant. Okay. All right, if not, it's fine. I can just repeat it. So that one was like, cosine and secant are the only even functions, right? The other 4 are odd, right? So if you take the first letter of cosine, which is C, and then the last 3 letters of secant, which is cant, ant, right? You combine them, you get cant. So you say that I can't even, right? So cosine and secant are even functions. And then the other 4 functions are odd. So those, if you plug in negative x, you get the negation of the original. Okay, whereas cosine and secant being even functions, right? There you get the original function itself. Nothing has changed. Okay, so does anyone still need to copy these identities? Otherwise, we'll move on to the next part. Okay. Well, actually, I'll actually leave these up here. The next part of the lesson, I'm going to have you work on the classwork, which is on Google Classroom. So there's 3 questions on the worksheet. So again, please go to Google Classroom and start the classwork worksheet. And I'll pause the recording for now. Any volunteers for 1? All right, let me ask Abu, are you there? Did you get something for question 1? It's all right if it's not correct. So tell us what you got. Okay, not there. Okay. Sam, you there?
Me or a different Sam?
Yeah, Sam Rosberg. Yeah.
Hmm.
Yeah, what'd you get for question 1?
I wasn't exactly sure. I had some trouble with this.
Okay. All right, that's fine. All right, let me go through it then. So the answer to this was actually secant. Okay. So the way we're going to do this is to, have common denominators. So we're going to multiply by 1 plus sine theta over 1 plus sine theta, and then multiply the other fraction by cosine theta over cosine theta, so that we get a common denominator of cosine theta times 1 plus sine theta. From there, you can add the numerators. So you get sine theta times 1 plus sine theta plus cosine squared theta. Now, sine theta times 1 plus sine theta is sine theta plus sine squared theta, which is what you see here. Okay. And then from here, cosine theta times cosine theta, that's where we get cosine squared theta. And then we have the common denominator, right? Now at this point, you know that sine squared theta plus cosine squared theta is 1. Okay, so it's sine theta plus 1 divided by cosine theta times 1 plus sine theta. At this point, you can actually divide out these terms, right? Because, sine, if you imagine this in parentheses, right, sine theta plus 1 divided by 1 plus sine theta, right? Those are the same quantities, right? Just, switch the order of the numerator or denominator. By the way, you get 1 over cosine theta, and we know that to be secant theta. So secant theta is our final answer. Anyone still need the solution here? Okay, if not, I'll move on to question 2. Let me ask initially, did anyone get an answer for question 2? Yeah, Dorothea?
I think I got cosecant.
Cosecant. Okay, let's see. This one. Oh, this one's actually also secant. Okay, but let me go through it. So initially we have sine theta plus cotangent theta times cosine theta over cotangent theta. You're gonna divide, the numerator by cotangent theta. So you get sine theta divided by the denominator plus, well, this time divided by cotangent is just cosine, right? Because the cotangent theta divides out. And then from there, we know cotangent is 1 over tangent, right? Alternatively, I guess you could also do cotangent is cosine over sine, but I'll just do 1 over tangent here. And then that cosine stays the same. From there, I multiply sine theta by the reciprocal of this denominator, which is, tan theta. And then at this point, I just make tangent, rewrite it as sine over cosine. Right? And then from there, I'm going to multiply cosine theta by cosine over cosine to get the common denominator of cosine. And then from there, we combine, right? So we get sine squared theta plus cosine squared theta, all divided by cosine theta. The numerator is 1, right? Because, sine squared theta plus cosine squared theta is 1. And then we'll have 1 over cosine theta, which is secant theta. Okay, so yeah, for questions 1 and 2 on the worksheet, they're both secant theta, and to do now is also secant theta. Okay. Lesson being, if you are ever stuck on the next quiz, just guess secant theta. Okay. All right. Anyone still need this solution here? Okay. All right. If not, then I'll move on to the last one. All right. Last one ended up being cosine. Okay. So here we have 1 plus sine y times secant y minus tan y. Okay. So we're just going to FOIL this. We get 1 times secant, which is secant, So I rewrite that as 1 over cosine. 1 times tangent is tangent, right? But it's minus, right? So it's minus tangent. Tangent can be rewritten as sine over cosine. So that's what we have there. And then that's followed by sine times secant, which is sine times 1 over cosine, right, for secant. And then lastly, we have sine times tangent. So sine times tangent is sine times tangent. Just rewrite that as sine over cosine. And that'll be a subtraction. Okay. All right. So at this point, we're going to combine the denominators or combine the fractions because they have a common denominator. All right. So we're going to have 1 minus sine squared. Right. That comes from here. It's sine squared. And then this is just 1. Oh, sorry. Yeah, sorry. I misspoke. This is 1 minus sine, and then plus sine times 1. So that's sine. That's what we get here. Okay, so this 1 is here. The negative sine y is here. And then sine times 1 is sine. That's right here. And then lastly, we have sine times sine, which is sine squared. And that's what we get here. Okay. At this point, divide all that by cosine. Yeah, so that's what we have for the entire fraction. And then the middle two terms, that sums to 0. Okay, so negative sine y plus sine y is 0. And then 1 minus sine squared y, we can use the Pythagorean identity, right? So sine squared plus cosine squared y equals 1. I just write here for reference. So we have 1 minus sine squared y in the numerator. So in other words, if we subtract sine squared y from both sides, we get cosine squared y equals 1 minus sine squared y. Okay, so in the numerator, we can rewrite that as cosine squared y. And then, of course, in the denominator, we add cosine y. So one of the cosine y terms divides out, leaving us with cosine y. Okay. All right. But that's actually the lesson for today. Before you go, though, let me just say that there is SGI at 2:47 in case you have questions. Also, the makeup quiz. If you missed last week's quiz, like quiz 3, if you missed it, then the makeup quiz is today. But you should have gotten an email from me if you were taking the makeup quiz. So just remember to, show up here at 2:50. Okay. All right. But other than that, though, you're free to go, and I'll see you all tomorrow. All right. Have a great day.
Have a nice day, Mr. Liang.
Bye.
Thank you.
Have a good day.
Thank you too.
Are we gonna have a quiz after Thanksgiving break, like on some stuff we?
Oh, I don't think so. I think maybe it'll be the week after. Yeah, but I'll let you know. Yeah, I don't think it'll be after. We won't have like enough topics, so.
And when do you think the last quizzes will be graded?
I'm gonna get to it, well, I started, but I probably won't finish until the end of the week.
Okay. Yeah. All right. Have a great day.
All right, thank you too.